Hey gang, happy Tuesday. Hope you're doing well. I'll flip back over here. Alrighty, you guys having a good time? Hopefully you had a good weekend. Quit that, sorry. Gotta close a couple more things here. Alrighty. So let me pull up our schedule here. And we'll take a look and see what we got going on. Maybe. Come on. It's loading. Come on. There we go. On Canvas. Yeah, look, they're having more trouble with other media site issues. That's unfortunate. Good thing we don't use that. That is not a problem for us. You just got to deal with Twitch ads, so maybe that's the trade-off, I suppose. I'm not sure which one you think would be better. All right, so I've got a couple. Still got to get the midterms graded for you guys. How'd they go, by the way? What'd you guys think? Thoughts, concerns about what you expected? Trouble, no trouble? I don't remember if I asked you. I think I asked. Didn't I ask? The days are all running together here. It happens about this time. Oh yeah, that was a week. Oh yeah. We've already done lists and dictionaries. Oh man. Don't know what day it is. All right, it's Tuesday. So the lab is going to set us up doing the little tic-tac-toe lab for what our next project is going to be. And we're going to talk about that one today. We're going to use classes and using a list. I don't think we need to use the dictionary for right now. We'll do that for other things later. We'll do that for 2 weeks. We'll have one last project with this files project, doing a files-based project. And then I'll give you your final project early in case you want to get started on it early. If not, we've got 3 whole weeks here to work on it. So it shouldn't be a problem. But we're coming up near the end already. So we're going to cover classes this week, and classes is huge. This is not necessarily everything you know in Python is class based. All of our libraries are and whatnot, but it's important for just foundational computer science and object-oriented programming. Everything is class-based, so we're going to learn classes. We're going to keep using them next semester, and you'll keep using them on and on and on. But for just general Python scripting, you can get away without them. It's really just a feature of making things easier for people. And hopefully that's the theme you've been picking up on, is code is for people. Right? The reason why we do all these things is for people. So classes are a way of letting us interact with code in a little more normal manner. And what I mean by that is we get to deal with things as objects. So, and you're familiar with objects. We talk about them all the time. Like, this is a can. There's lots of different kinds of cans, but looking at this can, you can see a couple things about it, right? You know what color it is. You probably know what's inside of it. You know how many ounces it holds. Those sorts of things. So those are attributes of an object, right? And typically classes are going to be nouns. It's not a hard and fast rule, but most of the time they're going to be nouns. And each class, then you can have more than one can, right? I can have this can or I can have this can, but they're both types of can, or instances of can, if you want to use our technical terminology. And each can has its own set of properties. Now they might be the same. They're both 12-ounce cans, sure, but they're different colors, have different flavors. Maybe I drank half of one, didn't drink half of the other, that sort of thing. So each instance has its own set of attributes that we can distinguish and keep separate in memory. I keep all those cans around just for you guys, of course. Just for you guys. All right, so let's do this one. Start a new project for classes. That's what, chapter 9, classes. All right, awesome. So what a class is it's essentially the blueprint for how we can use this object in code. And what I mean by that is we get to define a class. So we say, let me zoom in that in, like class can. Right? So everything inside of here is going to be part of the can class. And now there's some funny stuff that has to happen when we do classes, and that's okay. We'll figure it all out later. We're going to define the special method called init. And init and we say self. Now self is really special. When we're talking about classes, self is referring to the current instance that we're referencing. So each can will have a bunch of self variables. So I might say self.size in ounces, size in ounces. And it's always good to specify your units, because if you just say size or like volume or something like that, or maybe total, maybe volume is better, right? Volume in ounces, right? I'm going to start it off at 0, but I'm going to give it a value. So this will say every can that gets created now has its own variable for total volume in ounces. And I also want like a current volume in ounces. And I'm probably going to start that one off at 0 as well. So now I can create cans, and they will have values for total volume in ounces and current volume in ounces. So that's not super exciting, but we've used some classes before without realizing it too much. When we use some of the imports, right? We've been using classes. So to create a can, I might say, here's a can equals, and I'm going to now call the can constructor this init method here. So this is creating my variable name here. So it's variable name, right? And then what it is, right? What we're assigning. Now what's cool is after I do that, now, maybe we'll call this, what do we have here? I had LaCroix. How about a LaCroix can equals a can? Okay? And now I can say LaCroix can dot. And when I say dot, it's going to pull up a bunch of stuff. Now, there's a bunch of other things we don't really know where they came from. Don't worry about that. We'll get there. But I see current volume in ounces and total volume in ounces. So now I can go change those properties. So I can say, okay, the current volume, well, I probably should change the total volume first. I mean, it doesn't actually matter, but just to keep things, more straight in our heads, I'll go to my LaCroix can, and I'll take my current volume in ounces and set that to 12. So I'm setting some values here. Then what I can do is I can add ways that we interact with a can, right? Things that you might do with a can. You can drink from a can, right? As I drink from it, it reduces the number of ounces until we get down to 0. So I'm going to define a method called drink. And now, every time you write a method in a class, essentially, we'll get to some of those rules later, you're going to have an implicit self. So that means my current can. So when I drink, right, and maybe we'll say, if you want an argument, you just comma separate it, just like when we wrote functions. You just comma separate. Same thing goes with methods of a class or instance functions. Sure. Right. What do we call them here? Yeah, functions. So it's just functions belonging to a class level functions. So we might say, hey, this is ounces to drink. Right? Cool. So we're going to have ounces to drink. So we're going to take our current volume in ounces, and let's subtract the ounces to drink. Oh, but it says, I don't know what a current volume in ounces is, because, that's the self.current volume in ounces. Remember how we're passing in self? It's implicit. So this is my current volume in ounces. The can that's being drinking from, the can that you're drinking from, we're going to subtract the argument of ounces to drink. Then I probably want to do some sanity checking, right? One of the other reasons we do this object-oriented programming is not only do we get nouns to talk about, and they have their sets of attributes, and then we get the ways to interact with them through their methods, but classes are responsible for maintaining integrity. So I can check. I can say if self.currentVolume in ounces is less than 0, well, I couldn't actually do that, right? That's no good. Let's set it to 0, and then let's return false. We're going to say, hey, a bad thing happened here. You didn't actually drink all of the things you wanted to drink, but you drank most of it, or I mean, whatever, right? Whatever it was. Then you could have an else here. It's kind of redundant, because if you return, right, obviously nothing after that function is going to run. But that's okay. If not, we'll return true. We'll say, okay, sure, you drank some. So we make a can. I put 12 ounces of tasty flavored water in there. Variable. I can't talk. What we're assigning. So then I'll take my LaCroix can, and let's drink. So dot drink, and I have to tell it. Now I don't have to give it self. Remember, the self is implicit. So all I need to do is tell it how many ounces you want to drink. Let's take a 1 ounce drink. Okay, and then maybe we'll print. Let's do a nice formatted string here. So the can has LaCroix can dot current volume in ounces, ounces remaining. Okay, and we can drink a couple times, right, and just keep on going. We can see that each time we drink, we're going to reduce the number of ounces in our can. So it has 11 ounces, and then it has 10 ounces, and then it has 9 ounces. Right? So what we can do, if we want, we can put a breakpoint in here, and this is kind of fun. That one's not going to do anything. We put it in drink, and we run this in debug mode. We can watch and see all of the variables that exist. Debug mode is definitely your friend for troubleshooting. Okay, so I see I've got a LaCroix can. I'm sorry, I can't zoom that in very well. But it says it's a type of can. And I open it up, and it has two attributes. It has the current volume in ounces and total volume in ounces. So what's happening in memory at this location somewhere, I've got an instance of can, and then can is storing these two values for me. Right? And every can that I have will have that. So now if I step into, there's a step into my code. I want to do that. We're going to see it jumps to drink. Now my variables change. I no longer have the thing called LaCroix can. I just have self. Self is the LaCroix can, because we said LaCroix can dot. So this is implicitly saying, hey, this one is the self that we're acting on. We go to drink, and we see, okay, sure, now we're going to take out an ounce. So let's step. We return true. Great, we drink, we drink, we drink. We drink from our can. Now what's cool, right, because this is like a blueprint, you can have more than one can. Right, so I can make another can. I can have a, what was the other one called? It was that Kroger brand? Ice Mountain? I don't know which brand that is. Who makes that? Maybe it's just its own brand? Sure, we'll just call it Ice Mountain. So this is my Ice Mountain. Mountain can equals a can. Ice Mountain can. Great. And then I can say Ice Mountain can dot total volume in ounces, 12. I'm sorry, equals 12. And Ice Mountain can dot current volume in ounces is 12. And again, this is a little bit silly having to set these like this, and there's a better way we're going to look at in a minute. But what I can see, right, if I run it in debug mode, I'll see I've got both instances now in memory. They're both cans, right? But just like when we deal with things, oh, sorry, I need to do debug mode. Just like in the real world, you can have more than one of a type of thing, and each one has its own set of attributes. We'll see there are different locations in memory, right, and each of them have their own set of attributes. So the LaCroix can have different numbers, and the Ice Mountain can have different numbers. We're going to see they change to 12 here. So when we step, we'll see it goes from 0 to 12. And step 0 to 12 again. Oh, it finished. Sorry, there was no other code to look at. You can see, oh, sure, now we've got 12 ounces here. Right? We okay so far? So we're building a blueprint for a class that we can have in memory. Classes have attributes, right, that belong to each instance of the class, and then they have methods or functions, ways that you interact with those classes. What do you guys think so far? All right, that's okay. I'll assume it's okay. If it's not, shout at me. Right? I'll get the picture. So having to set these here is a little bit annoying, and having to set them at the same time. And you usually don't buy empty cans, right? You can buy like empty jars or bottles, but typically when you buy a can, it's already filled. So what we're going to do, we're going to change this init method and say, hey, if you want to make a can, tell me the ounces. And what I can do is I can set my total volume and my current volume to that ounces. Right? Or maybe I'll say, maybe it's total volume ounces, whatever it is, right? So if you give me a number, I'm going to take that number and set it. And now what happens is it's going to be upset with me, and I won't be able to run this. When I go to run it, it's going to crash. It says, oh, init is missing one required positional argument, ounces. Because we said when you make a can, you have to tell it how many ounces now. Which is actually nice. So I can just say 12 ounces here. I can say 12 ounces here. Right? And I can print like my Ice Mountain can, right? This is my Ice Mountain can, volume in ounces. I don't know, Ice Mountain. Mountain can, sure. Now let's run this guy. Oops. I have too many? That's the right number of parentheses, right? Nope, one more. Oh, no, I don't want to print again. There, okay. Let's try that. Oh, I can't spell mountain. Mountain. Right? Sure, now we have both cans, right? If I do this in debug mode, we'll see again both sets of cans here. And then what I can do at this line here, if I step in, I can actually see the init method run. So I'll see it, I'm setting total volume in ounces, because when you call can, right? So init's a special method. It hooks it up to the name of the class. So I don't call class.init and have to give it things, right? I just call the class name and I give it the arguments here. And I'll see it goes and sets those to 12. And now I have a LaCroix can, and I have a nice mountain can in main here. So I can have my class. It's kind of cool. I'm going to pull this up and make sure I'm not missing anything for you guys. Try and follow along best we can. Yeah, chat is quiet. I guess you guys forgot all your coffee. It's Tuesday, right? Yeah, Tuesday. Pretty good time. All right, good, good. Yeah, classes, they're ways of like grouping data together. Sure, I like that. That's fine. All those attributes. An instance method, something that belongs to the class. Good, we did those. Classes and types. Yep, yep. Okay. All right. Yeah, we're doing good so far. We're doing good. And then I give you a little example. Sure. The constructor, our init method. Good. So there's a technical term we might run into. It's called the interface. So the interface, or the API, the application programming interface, is all of these public methods here. And in a lot of languages, you have this idea of things being private and things being public. Python doesn't really do that. Python is what we'll call trusty. So Python trusts that you're going to do the right thing here. Yeah, so init is the special method that creates the instance of the class. So when we call can, or can12, and we give it 12 ounces, it is creating the object in memory. So it's the init method's job, or the constructor's job, is to set values to all of your instance attributes. So it's the special method that gets called. So we never call it by name. We just say, hey, I want a can, and we have to give it the arguments for init, in this case. Because it's a special method. I could probably stop that here. So init is special. It creates the object. So a lot of times, like we'll do some silly classes here, like a square. And we'll have an init method for square that takes the length in, how about inches? Oh, let's do centimeters. Length in centimeters. Sure. And we'll probably set a side length equals to the length in centimeters. So the constructor's job, or the init's job, is to set values to all of these self.attributes. Any attributes that your class knows about itself should get set in init. And then we can have a method like get perimeter. And what we can do is we can calculate the perimeter of our square. Right, so we're going to return self.sidelength times 4. And how about a get area? Right, area is self.sidelength to the power of 2. Right, so we can do things with square. These are ways we can interact with that class. It's a really basic example, but it's nice. Like we can compute values here. So we can build objects, and each square can have its own length here, and we can do some arithmetic. Right, we might have a class for, how about a lamp? We'll define an init method for lamp. And lamp probably doesn't need a whole lot of information. passed to it, but one thing that it knows is on, right? The lamp will know if it's on or off, on or not. And it's probably going to start as not on, as false. And then maybe we have a toggle method, a way that you interact with the lamp, like you flip the switch, or you pull the string, right? Whatever it is for the lamp, you do the light switch, you just toggle it. And is on then changes to not is on. Right? If it was on, it's going to be off. If it was off, now it'll be on. And maybe we'll have a method for is on, and it just returns self.isOn. Nope. Right. It will figure out whether or not we are on or not. Oh, it's unhappy with that. Why is it unhappy? Probably because we're using the same name. Function name, oh, that's right, is on. Is on. Oh my goodness. Right, so we can figure out whether or not a lamp is on, we can figure out the sides of our square. So the lamp, like, it just, you can turn it on and off, you can figure out whether or not it's on or off. Right, maybe it's one of those really smart lights here. So maybe we have a self.color. We'll assume it's white, unless you tell me otherwise. And then maybe we'll have a way to, this color attribute we can just go get, right? We can say, hey, give me what the color is. Oh, that's right, we were talking about public and private. So other languages have ways of actually protecting values. Sorry, I gotta mute for a second, I'm gonna sneeze. Oh, shoot, I missed the mute button, I'm sorry. Hopefully I didn't blow your ears out there. Oh, I thought I clicked it too, I'm sorry. So this idea of a value being private means that you shouldn't be able to get access to it from outside of the class. And why that's important, oops, go back. Why that's important, the idea when we build objects and we build classes is they need to maintain their own integrity. Right? With our can here, you can't drink more than there actually is liquid. There can't ever be a negative volume. Right? That just can't happen. So the class's job is when you interact with it to ensure that doesn't happen. Now the problem is you can just go change that value yourself, right? We could, if we wanted to, we could take a ice mountain can dot current volume in ounces and say it equals -1. That's not really ideal. I mean, we can, but we shouldn't be able to do that sort of thing. So what we can do is Python has a convention where we'll do things a certain way and people will assume that that's the right behavior. So in can, what we can say is this is an underscore self value. And if a argument or an attribute starts with an underscore, it is assumed to be private in Python, and you shouldn't touch it. Doesn't mean you can't, right? You still can mess with it here, and Python is trusty, right? It's going to trust that you're going to do the right thing. So I can take my S mountain can, but now when I put dot in, notice it's not showing. So like the tools that we use to develop in Python hide those things away, but if you just scroll down, where did it go? Oh, it did hide it. But if you do underscore current volume in ounces, like we can get access to it and we can go change it. Nothing prevents us from doing that, but it's considered bad form. Volume, can't spell. So you're not supposed to go touch things that are private, and sort of the rule or the contract here is if you do, the class might screw up. Right? If you want the class to do the things the class is supposed to do, don't go mess with private values. Right? So if you want it to work the right way, don't access them. So all of our methods here, all the ways we're trying to get our volume are going to fail. So this isn't going to work anymore for us because it has no attribute, current volume in ounces. Now we could go get the private value, but that's not ideal. So what we want to do is want to give a method, a public method, like get current volume in ounces. So what we do is we have private attributes and we expose public methods. These public methods are part of our interface or our API. The application programming interface, the API says these are the things you can do with my class. This is how you're supposed to interact with the class. We just return self.current volume. Okay, so we can write a method now, get current volume in ounces, and I can use that here. So I can use that public method and interact with its interface and say, okay, hey, do this thing you said you're going to do for me. And now it's going to work. So what it lets us do is we get to hide away our attributes. So this idea in object-oriented programming is kind of abstraction, kind of encapsulation. We use the terms, they're very much related. The idea with abstraction is you get to deal with this class as an abstract thing. You don't need to know how it works. I mean, we wrote it so we know how it works, but if you think of like random, we say random.next or randint, we don't actually know what the random code is doing, right? We're working with the abstract version. It has a interface that says, hey, you can get a random number, and we say, okay, cool, I want to use that random number. We don't have to understand how it all works. We do the same thing with our classes. So we're building out this abstract interface that they get to call these public methods, public functions, and we do the stuff. Anything that's private means they shouldn't touch it. And again, you can go screw it up, right? I can take my ice mountain can dot current volume and ounces. Oh, there it is. Current volume and ounces equals -1 and screw it up, right? And this will run. Now I have negative ounces. So if you're accessing stuff that's private, you're pretty much saying, okay, I might screw things up. I might break stuff, right? So a lot of times, your instance attributes you want to be private, and then you want to give public access. So a pretty common form in other languages, and it's perfectly fine in Python. You might have a set method, current volume in ounces. In ounces. So if you want a variable to be set by somebody, you write a method that accepts an argument. So volume in ounces. And then we can set the volume. We can make my current volume match their current volume, or whatever they give me. Now, you don't always have to have a set method, though, right? Some attributes you don't want to change like that. You don't want to just say, tell me whatever you want. So maybe that's a bad example here. But how about color, like with our lamp here? Maybe we want to change the color. Let's say set color, given a color. I'll take self.color equal the color you gave me. And notice self-color is my instance attribute, right? This is the one that belongs to my instance of lamp. The color over here is the color argument, whatever you gave me as color. So if we want to be able to set the color, sure, we'll do that. And then I can figure out whether or not we're on or not. Does that make sense? So in this case, I want a set color, and I also want a get color. Define get color, returns self.color. And then what I can do is I can make this color here, and if you do this refactor rename, it's going to be a lot easier for you. So you don't have to do all the replacing yourself. Right? I'll probably do the same thing with isOn, right? So let's refactor rename this. That's probably be a private isOn attribute, so I don't want them to change it directly. I want them to go through toggle. Well, that should be self.isOn. There we go. Okay, I think I had it misspelled there. So you have public methods then that give you access to my private attributes. So I'll tell you what the attribute is if you call the public method. And again, the idea is we have some protection over what happens here. Now with the lamp, it's either on or off. It's not super interesting. With drink, right, making sure we don't go below 0. So we're able to put in the sort of logic that maintains the integrity of our class. So I talked about abstraction. The idea with encapsulation is we're taking all of the details of can and we're encapsulating them into the can object. Right? The class can represents that noun. It has the attributes and it has public functions here. We've put all that together here so you can just have a single can. All of those details are encapsulated together. Right? You have one thing that you can deal with. It's just a can. Typically, what that also means is we're protecting our attributes. We're making sure we get good values here. So maybe we want to check. We can say if ounces is greater than 0. Or how about we'll say if it's less than 0, we'll set ounces to 0. Essentially, you have a plate here. You no longer have a can, just plate, right? You can't hold anything in a plate. I mean, plates usually have a little bit of a lip, but we'll pretend, right? So we're going to do a little bit of sanity checking, right? We're encapsulating our way. We're going to protect ourselves, maintain the integrity of our class, make sure we don't get bad values. Let's give that a run. right? And it still does all the right things, which is cool. So you can make lamps, we can make squares, right? This sort of thing. So classes are pretty powerful. Right? I mean, we could have done all that exact same stuff without a class, right? We could have just grouped things together. You could have had dictionaries of things, but the class lets you have, it's an easier way to represent it, right? You don't need to try and figure out what the dictionary actually is and have functions that take dictionaries and whatnot. It just gets funny, right? So this works out really well for us. Now, some funny things that you can do, right? Once you have a class here, so we've got a square, takes a length in centimeters. Some fun things that you can do is you can define a special method. So there's a bunch of methods that start with 2 underscores. These are like special operators or things. So we can define how this class gets turned into a string. Where's my str here? We'll find it. There we go. So actually, let me comment that out for a second. So let's make a square. So small square equals square, and let's say maybe it's 2 centimeters. That's pretty small, right? And we can print, we'll do a formatted print, oops, that way is a small square, has a side length of, so it's small square dot side length, right? And then maybe we'll do a couple of these. Length, I can't spell. I love that the spell checks for me, because that's like super handy. And a perimeter of, and then we'll call dot get perimeter. And how about an area of, we'll call get area. Right, and these are probably all in, like we know these are all centimeters. An area should be centimeters squared, right? Right, so now we'll see if our side length is 2, the perimeter is 4, area is 4 square centimeters, centimeters squared. Right, we okay with that so far? And maybe we should do the same thing here. Let's make side length be private here. So I'm going to refactor, rename that to underscore side length, and then we'll add a method for get side length. Get side length. Again, you want to have public methods that give access to the attributes if you want them to have access to those attributes. You don't have to have set methods. Like once you make a square, we're not going to give you a set side length because it shouldn't change, right? Once you make a square, it's that size. You can't like stretch a square out. You can make a new square with a new side, right? So this isn't going to work here. So we want to get side length. Okay, cool. So let's make another square. And you know what? It's kind of annoying to have to do this, right? So what I want to do, I'm going to be fun. We're going to define a method for like print square info that says, hey, you give me a square. And maybe we'll say this square. I don't know. There's no names on these things, so we'll just say this square. And I can say print square info, and I can hand it my small square. Right, so once we have a class, once we've got that object that we're interacting with, we can hand it to different methods. We can define methods that take types of our classes. So sure, I get all the same info, and I can make another square. Let's make a big square. Let's say maybe that's, I don't know, 2, 3, 4. And we should get the same info out. Uh-oh. Oh, I passed it small square. We got to pass it the big square. That's probably why we got the wrong info. Let's try that again. I'm in class, what's up? It's right here. Nope. Where is it? Oh, it's downstairs, isn't it? I think it's, that's right. I think it's downstairs. Do you have your piano lesson? All right, I'm gonna have to get my daughter set up for piano lessons in a minute. But anyway, right, if we give it the right one, actually pass a big square, we see the big square information. So other fun things you can do, right? There's other things, this string here. If we want to be able to, oh, that's what we were going to do. I'm sorry. So just saying like print small square here, we get some funny looking thing. So if you just print small square, you get, it's a main square object at memory location. It's junk, right? But you can, it just doesn't give you anything good. So if you want to be able to just print an object and not have to like do your own prints here, you can define this under str for string. How do I turn myself into a string? What you do is you return a string. So we're going to return a formatted string of what's self dot side length. I don't know, so we'll just do all this like side length, and then how about perimeter, self dot get perimeter, and you can call your own methods, right? You can call a method from a method. You can do all that. It's perfectly fine. Area. Sorry, this is getting long, but self dot get area. I'll fix it in a minute. Here, so let's pop some of these down here. I think I can do it like that. There. Yeah, so those slashes are like, hey, I'm going to trail onto another line here. So now when I call print small square, we should get the thing I defined. This was a string that I said, hey, here's how I'm going to build a string. This is how I represent the string object. I know, it's a lot. It's a lot to go through, and it's kind of a shift in thinking. Oh, that's the wrong thing. I wanted to pull up the Zybooks and make sure we're kind of following along here. It's a tab, not a new window. Oh my goodness, come on. All right, some other really helpful ones that you might want to define. We can say, are we bigger than or less than? So we can say, define less than. So is myself less than another one here? Right, so how do I compare two squares? So if I'm less than, I'm going to return self.sideLength is less than other.sideLength. And maybe we should use our public methods, right? Get side length. Let's do it that way. Right, that's how I'm less than. We can define an equals to. We're going to return if our side lengths equal. Right, and define a greater than. Now, this one, you can be tricky if you want, right? If we're equal or less than, this is false, right? Because if you've done 2 out of the 3, you know you can only be less than, equal to, or greater. If I know how to figure out if I'm less than, and I know how to figure out if I'm equal to, I can just return not one of those. Sure, and that's kind of a fun little shortcut. So this is a shortcut. The efficient, lazy way is we're going to return not self equals other, right? Because if self equals other is true, we need to return false, right? Or self less than other. If either one of these is true, I want it to be false. If neither of them are true, this whole or is false, and not false is true. Does that make sense? So we can compare squares now. So I can print small square is less than big square. Right, let me do this in quotes. We'll do a formatted string, right? And you got it? Awesome.
Sorry.
Oh, that's okay. We'll get you logged in.
You still in class?
Yep.
Can they hear me?
Yeah, say hi.
Hi!
All right, here you go.
Bye.
Yep. Can you close the door, please? All right. Hey, Blowfish. Thanks for hanging out. Yeah, I gotta close my door real quick. Alrighty. So if I want to say, hey, am I less than the big square? Colon. And then let's put this in here. All right, and then we'll check if we are greater than, we'll check if we're equal to. All right, let's give those a look. Greater than. So small square is less than true, equals false, greater than false. Cool. Now let's, just for fun, let's try that with our cans, right? Let's print a formatted string of LaCroix can less than, what was that other can called? The Ice Mountain can? There we go. And let's grab that. Let's see what we get. And we'll do the other ones too. Why not? If it equals, and if it's greater than. Okay, let's see what we get. Uh-oh. Doesn't work. It says it's not supported. You can't compare, because if we haven't defined what a less than is, how would Python know what to even do? So if you don't even have it, these just fail. Right? So this, we don't have the functions defined, or methods defined. So I'm going to comment those out, right? Because they just don't work. Technically, this one will work, actually. This is a funny one here. Equals will work. Greater than, less than. What equals is doing is right now it's checking, are they the same location in memory? So it's not a really good equals one. This checks if they are the same object in memory. So if I do that and then I say, hey, LaCroix can is equal to the Ice Mountain can, and then I try it again, they should match. Right? Because now they're actually the same thing in memory. So if I run this in debug mode and take a look, you're going to see, let's see, oh, we don't need that one there. Let's keep stepping. Step, step, step. Okay, so here I've got an Ice Mountain can at somewhere 908 and a LaCroix can at like EB8, and then we set one equal to the other. Now we see they reference the same location in memory. And look at that, PyCharm's even saying, hey, they're protected attributes. Don't mess with these. Now, what the bad thing is here, when we're dealing with references, right, they are the same here. I can take LaCroix can, I can call drink, and I can take my Ice Mountain can, I can call drink. Now, what do you think is going to happen here when I drink from a can if they point to the same can? What do you think we're going to get? Okay, so we set, now they both point at the same location in memory, so the LaCroix can is an Ice Mountain can. Right, so all the drinking we did from the LaCroix can is gone, because now it equals the Ice Mountain can. So now they point at the same can. So when I drink from the LaCroix can, my ounces, where did it go? Did I not step? I thought I stepped. Uh-oh. Didn't I step? What happened? What happened? Let me put the breakpoint here. Let's run. Uh-oh. Oh, we got to tell how many ounces to drink. Let's drink 2 ounces. Come on. Come on. That was the problem. Okay, so our Ice Mountain can and our LaCroix can, right? They both have 12 ounces now, because we never drank out of Ice Mountain. When I drink out of LaCroix, notice it changes the Ice Mountain can too, because they're pointed at the same location. It's actually the same can. So setting one equal to another is dangerous, because now I just have 2 variables that point to the same one in memory. I don't have 2 different ones anymore. So you gotta be really careful with this assignment operator. And we'll get more into this next semester, dealing with this assignment operator, because it's a big pain. And we've got ways to deal with that. But you just gotta be careful, okay? All right, cool. So that's that. Other operator overloading, you can define like how you add 2 classes together. We could say a can plus a can equals another can. And it doesn't always make sense. So like you don't have to overload operators. It's just a convenience. And if it makes sense for your classes. So the book has a great example of like a time class that represents hours and minutes. That's really good. Right? We should be able to do that sort of thing. And you can overload any sort of operator. It's really cool. All right, yeah, memory address, garbage collection, that's good. All right, yeah, that's actually, we did really good. So I've got more things I want to work on. There's tons of lab exercises because this takes lots of practice. It's a new concept, it's a new way of doing things, dealing with classes. So I'm going to give you back some time, work on those lab exercises and practice. And when we come back on Thursday, I'm going to tell you about unit testing that is not in the book. Not in Zybook, but it's a super important topic, and it's really helpful because we're going to make sure the computer can do all the checking for us. And then once we've covered unit testing, then we can go over the next project. So I want to cover the unit testing first because we're going to do unit testing in our next project. So I want to give you a little bit before we start the next one to cover the unit testing, okay? So I think that's all I got today. We'll pick it back up on Thursday. We'll do more classes. Again, do the practice in Zybook. Right? Go through those labs, work on them, build out the classes, do the things it asks you to do. It definitely is going to take some practice because this is like a new paradigm in thinking now. All right? Before we just had code go top to bottom, and then we had the branches. We could go into blocks, we could go out of blocks. Yeah, I'll put this in GitHub, good idea. And then we said, okay, now we can write functions that are repeatable code. You can make arguments. We can put nice names to our code here. 1501. Now this paradigm is classes, where we can say, hey, anything that's a noun could be a class. The attributes of that noun become its attributes, like its self.attributes, the instance attributes, and things that you do with that noun become its methods. Right? And we can take that concept really far, which is really cool. This is classes part 1. So we'll do more with it on Thursday. We'll practice. We'll do a lab with it on next Monday, and we can go from there. So it's okay if it's a little fuzzy, right? It's gonna take practice. It's a new way of thinking about things. To say, okay, things belong to my class, and then we have this self variable that's implicit all the time. The self refers to the current instance that we're referring to. So self, like anytime you say like your object here, LaCroixcan dot, LaCroixcan is self. That's the current instance. That's the self that we're passing implicitly when we call these methods here. So it's automatically filling that for us because it knows, hey, we're calling it using this one here, this one that I'm referring in memory. Okay? All right, cool. So that's all I got for now. If you got questions, find me in Discord and you can ask away. And then I'll work on getting the midterms graded for you guys. I should have those done by Thursday for you. Okay? If you got any other questions, let me know. If not, we'll call it a day. You guys take care.